Hello, everyone. I'm Florina Muntenescu. I'm an engineer in the developer relations team.
Hi, I am Siyamed Sinir. I am engineer in UI Toolkit team.
Hi, my name is Seigo Nonaka. I'm also engineer in UI Toolkit team.
Last year, we told you the basics of best practices with text. And this year, we want to build on top of that. So if you haven't seen that talk yet, go check it out. We'll wait. This year, we looked again at topics that you have most problems with, the ones that you feel are most challenging. So in this talk, we're going to cover a variety of topics. Some are wider, more generally applicable, and some are more niche, advanced topics. And the solutions, as you'll see, are either new APIs in queue or some specific guidance. So let's get started.
OK, let's get started from performance. The performance is a top topic in the user experience, and text is one of the most heavily used components in UI Toolkit team. Despite from the usage, most of the internal things are black boxed and hard to optimize for many of developers. We have been keep improving the text view performance and show some useful tips in last Google I/O. This year, first, let me announce that the hyphenation is now turned off by default in under the Q and AppCompat version 1.1. As we talked last year, the hyphenation has a huge impact to the text view performance. Actually, the 70% of the text work is for hyphenations. So we turned off it by default. If you need hyphenations, please manually turn it on in your application. To enable the hyphenations, please set hyphenation frequency attribute to normal in style XML or layout XML. Also, you can call set hyphenation frequency method in your code. OK, next. We released the pre-computed text in last Google I/O. This is a tool for doing text work in background set. This does 90% of text work beforehand, selecting fonts or measuring text. This is a set-safe object and should be created in background set. And we backported this class to Jetpack and available from API 21. Then this year, we added new utility APIs for easy integration with RecyclerView prefetch. Before looking into the details, let's see the overview of the RecyclerView prefetch. This figure shows the workload of US thread and render thread. US thread does some work and passes the rendering work to render thread. The eye icon shows the timing of vsync. This figure shows a good state. Nothing blocks the vsync event. But if some work takes time and couldn't finish until the next vsync event, it ends up with a UI junks. In this example, the red work takes time and blocks the next vsync event. This typically happens when the new item is appeared by scrolling. The idea of prefetch is doing this new item process in much earlier time when the UI set is idle. If everything goes well, the workload of the UI set has distributed, and we can prevent UI junks. This is just an overview. So if you need more details, please check the articles on the Android Developer Medium publication. This is how prefetch works, but this prefetch has still limitations. The prefetch still works on the UI thread. If prefetch takes longer time, that prefetch still blocks the vsync event. This typically happens when you set long text to text view. One obvious solution for this problem is moving some work to background set. Actually, you can move some text work to background set by using PrecomputedText. However, in general, moving some work to background set is not a trivial work. So we introduced new utility APIs for make this happen easily. The API is getTextFuture in PrecomputedText compat and setTextFuture in AppCompat-TextView. Let's see how it works. When you write the application with RecyclerView, you may set text in onBindViewHolder callback, like this. Then, if we move the text work to background set, the code looks like this. Let's see line by line. First, let's call getTextFuture. The getTextFuture schedules text work on the past executor and returns the future of the result. Once you get the future, you can set it to the AppCompat-TextView by calling setTextFuture. Basically, that's it. By calling these two APIs, you can move the text work to background set. This is pretty simple, but please note that you cannot change the styles after calling getTextFuture. Because getTextFuture schedules the text work with the parameters when it is called. So if you change the style after that, the async work result won't match up with the parameters of the text view. Then it ends up with an exception. So if you want to change the styles, please do it before calling getTextFuture. If you need more details or what is under the hood, please check the article on the Android Developer Medium publication. Thank you.
Apart from performance, another thing that everyone needs to work with is text styling. But with so many ways of styling text, which one should you use? And what's the precedence order for each of them? So one of the easiest ways to style text is by just using the text view attributes. But the problem with this is that this is tedious and error-prone. If you, for example, need to update the color of the text views, you need to see absolutely every text view in your application and then do that update. The solution for this is working with styles. They bring you consistency, reusability, and easy updates. And this actually brings us to the first precedence order. So you see here we have both the text size in the style and also in the text attribute. So which text size will the text actually have? Well, the view attributes overrides the one from the style. So what you'll see here is a text that's 16 SP. Views have a default style. So for example, for the button that's a subclass of the text view, you'll see that we're also using a theme attribute. That's the button style. Well, in the material theme, this points you to a certain style, which styles different elements, including attributes of the text of the button. By setting your default styles, it means that styling becomes an opt-out rather than opt-in. By default, all buttons, independent if you're adding them to new screens or you're refactoring, will have a default style. So you'll only need to modify them if you specifically want to change the style for the button. So by default, but this default style is going to be overridden by any style that's set directly on the view. The button properties, as some eagle-eyed might have seen here, are set using the text appearance. So text appearance actually functions very similarly to a style. Under the hood, the text view checks whether the view has a text appearance, it loads it, it applies it to the view, and then it adds all the other attributes like the text style also. So this means that as a precedence order, the text appearance is then overridden by the default style, and then the view attributes. But there's something you should know about text appearance. It's character building. It only supports character-level styling. It doesn't support paragraph-level styling like line height or break strategy. These can't be customized here. In Android Q, we added a new attribute in text appearance, the font variation settings. And the same attribute, starting from Q, can be used in text view and in app-compat text view. Some of the text appearance attributes are also supported in text appearance span. Before Q, the text appearance span didn't read some of the text attributes like typeface or shadow. So starting from Q, the text appearance span is updated to read and apply these attributes as well. Also new in Q, speaking of spans, we've added implementations to two new spans, line height span and line background span. When applying a span on top of text styling, keep in mind that the properties of the span, the properties that are set by the span, will override any other properties that you might be setting via a style or default style or view. But what if you want to change some attributes of the text view at the app level? So let's say that you want to change the entire font in your application. Well, for this, you would use themes. So for example, here, we're setting the font family attribute to set the theme. The theme is part of the view styling system, and it overrides anything that's supplied in the text appearance, but it will override any more specific attributes. So for the text styling, we looked at the precedence order to help you better understand why, or why not, style is applied.
Thanks. Hi again. Thank you. So we have covered tips related to text styling and also performance. And we will continue with fonts, which is an important part of text styling, and also your application's brand identity. Over the years, you have mentioned us about the shortcomings of font support on Android, and in the last few years, we have added features such as downloadable fonts and fonts in XML. This year, we have improved the typeface and font-related APIs based on the further feedback we got. Let's go over a real-life use case, and let's assume that we have an app, and in one of our buttons, we want to use an icon in between the text. And we want this icon to be rendered using the icon font. And for the remaining of the text, we want to use another custom font, let's say Lato. When we want to do this, we are kind of in trouble because the button will accept only a single typeface, and a typeface can be created using a single font or font family. Actually, in the current API, we can use a typeface span, give the icon font into it, and cover the icon character. And then for the whole button, we can choose to use the Lato font. However, things will get much more complicated if we were to try to support multiple languages with their own custom fonts. Using spans here is definitely not a scalable solution because you will have a lot of languages to support, and it's pretty hard to accurately identify different languages for a given string. And on top of that, over the years, I have heard continuously parsing emoji, for example, is pretty hard. And if you have another custom emoji font, that would be a pain. Therefore, on Android Q, we added custom fallback builder to the typeface class. It enables you to create a typeface using multiple fonts or font families. When we check our multi-language use case, here we create a builder. And for each of the languages, we create a font family and add the related fonts into them. And this will also solve the icon font use case as well, where this time, again, we put the icon font as a separate font family into the final typeface. When you have multiple styles for a font family, you can add them into the same font family object. And whenever you set the text view to use bold style or mark a portion of the text to be bold using spans, the system will choose the correct bold font from the given configuration. When creating a typeface using this builder, you can add up to 64 font families. However, what you cannot do is you cannot put the fonts that belong conceptually to different font families into the same font family object. The reason is the system expects the fonts that are in the same font family to have the same code coverage, which means that they have to have one-to-one mapping between the characters that they support. And the other thing that you cannot do is to put two of the same styled fonts into the same font family. For example, here, if I were to put Lato bold twice into the font family, same font family, I would get an exception. And when you define a custom fallback builder, here is how the system works. It does a sequential search over the string and also over the fonts that are provided. For example, in here, it will start with the Japanese character, and it will check if Lato font supports this character. If not, it will go to the second one, C Kosugi, and at that point, it will try to cover as many characters as possible using the same font. And then it will do the same thing over again. And if the string contains a language that is not supported with the given font, the system will use the system fallback use case, which is the current case for Android and typeface. As a control over system fallback, the new APIs has a function named setSystemFallback, where you define what kind of generic family should be preferred while choosing a font from the system fallback. Since Lato is a sans serif font, here I tell the system that if a character is not supported by Lato, the font that I added, I want system to prefer a sans serif font. Just like the current typeface builders, you can set, while creating a font, you can set the weight, slant, and also the variable font settings on a font object. And finally, in terms of font matching, let's assume that you added two different weighted fonts into the same font family, 400 and 700. And by using text font weight on TextView, text font weight attribute on TextView, you requested to render this text using a 600 font. In such mismatches, the system will use the closest match or style. For this case, it will choose to use 700. Text font weight was recently added, I think in P, to TextView, and it's also currently being read by text appearance span.
Thank you, Siyamed. As he explained, we expanded the font experience under the queue for Java applications. On the other hand, there's another strong demand from NDK application developers about system fonts. So we decided to add new APIs for accessing system fonts from native code. This would be a great tool for NDK applications who draw text on the screen, like games, document viewer, or browsers. First, what is a system font? Android supports over 100 languages, and each language may require different font files. For example, to draw Hindi, you may need Devanagari font. In case of Pixel 3, to support this large number of languages, it has over 270 font files are installed. To draw text, NDK application, like document viewer, needs to know which system font can render the given text. This is not a trivial question, so we added new APIs for this. The API is Font Matcher API. This is the interface of the system internal font selection engine. This font selection engine is also used by the text view, so you can get the same result as in the text view. OK, let's see how this works. Let's think with this example. The core API is a font matcher match function. This takes a search string and returns two output, font and length. Please note that this API is simplified for explaining behaviors. The real API is written in C and takes more parameters. Anyway, this function would return, in this example, font Noto-san CJK regular and length 3. This length 3 means first 3 characters can be rendered with the return font. In this case, Noto-san CJK. OK, now we know the font for the first 3 characters. What about remainings? Since we know the first 3 characters, let's advance the search range. In this case, starting offset by 3. Then call the same function again. On the second time, this API returns font robot regular and length 8. Again, this 8 means the next 8 characters, in this example, it includes a white space, can render the robot regular font. Then advance the search range, then call function again. On the third time, now we reach the end of the string. So we get all fonts for the given characters. As you've seen it, by keep calling these functions, you can get font files for all characters. This is how this API works, but please note that this API never returns null pointers. Even if no font can render the given font, this API still returns a valid font object. This font object should be used for drawing missing Greek symbol called tofu. Similarly, even if there is no font exactly matches with the given parameters, this function still returns a font which should have a closest style. OK, this is font matching API. This API gives an answer to the question, what font should be used for the text? On the other hand, there's another frequently asked question. What fonts are installed in the device? To answer these questions, we also add new APIs called Font Enumeration API. This Font Enumeration API gives you the access to the system-installed font files. Let's see how to use this. The Java API is very simple. You can just call system fonts get available fonts. This gives you the set of system-installed font files, and you can get a full path of the system fonts. In case of NDK, it starts from creating iterator object. By keep calling iterator, next function to iterator, you can access all system-installed font files. But please note that the returning order doesn't mean anything here. For example, even if font A comes before font B, that doesn't mean font A has higher priority than font B. This next function returns in random order. Finally, there's another note here. This font enumeration API is not so fast, so we recommend you to cache the result. Since the system font configuration is read-only and modified only by the system update, so you can keep the result for a longer time until the next system update. Thank you.
One of the most used subclasses of text view is edit text. And pretty much everything that applies to the text view also applies to edit text. But on top of this, there are also other things that you need to handle, things like layout, styling, keyboard configuration, input formatting, internationalization, and more. Unfortunately, we don't have time to go over all of these today, but we will cover some of them. So first of all, when working with edit text, you actually interact with 3 different processes. The first one is your application. The next one is the soft keyboard, named input method service. And then the third one is the system process that orchestrates those two. And because this is an inter-process communication, you might see in some cases a slight delay between key events entered in the UI and them showing up in the app. So visually, edit text has the following components: the hint, the text, the background, the selection, the cursor, and the cursor and selection handles. The background, cursor, and handles, the colors for these are updated when you set the color secondary in your application theme. They're actually just drawables that use color control normal and color control activated in their definitions. So actually, you can also modify those theme overlay attributes to change their color. Each of these drawables themselves can also be updated using related attributes, but probably the one you want to set the most is edit text background. Finally, text color hint, edit text color, and text highlight color are also used to update the color of the other three. Apart from these attributes, just like TextView, edit text has its own default style, which is the edit text style attribute. And this can be ported to your own custom style. So use this attribute to change any edit text view attributes, such as text size or text style.
As you all know, edit text has support for compound drawables. And sometimes we see those compound drawables are being used as action buttons on the edit text, such as a clear action. However, using drawables as buttons comes with a lot of constraints, and it definitely negatively impacts the final user experience. Things like when you add an action button, you will probably want to show the ripples on touch, maybe animate the icons, have more than one icon on each side, and then you will also have the accessibility requirements. All of these features are already supported by the existing view and layout system, and therefore we would suggest to use them instead. Apart from being convenient at first, I believe that there might be two reasons why people would like to choose to go that way and use the drawables. One of them is having the same edit text look and feel over the whole group, and the other one is being able to contract and expand the editable area based on the visibility of the button. You should definitely use text input layout, and that will cover a lot of use cases. However, if you have application-specific requirements that are not supported by text input layout, you should create your own view group and layout. And in order to address the issue of having the same look and feel, you can set the edit text background to null and use the exact same background that is already in the system for the view group. The only thing we have to do is, in order to respond to the state changes for the drawable, such as pressed and focused, you have to add the add states from children attribute to the parent layout. Another common issue in terms of edit text that we are aware of is how the keyboard plays with a possible input validation error. Depending on the location of the input field, the error can remain behind the keyboard, and you really want to see the users to be able to see what went wrong, let's say when they were going through a sign-up process. This is currently the case also for the text input layout, and there is an open ticket about it. But until we get to address this issue in the material library, here is how, what we can do in order to make those errors visible. There is already a system in place that keeps the editable area visible after the keyboard shows up. And all we want to do is to tell the system, instead of the edit text area, which is the green box in here, use the yellow box. And in order to do that, we have to extend from edit text and override three functions. I have added a sample code to the URL given in the slide, but I will go through the functions briefly. Get focused rectangle is used to find the next focusable widget, returns a rectangle or updates a rectangle. Get global visible rectangle defines the visible area of a view. And finally, request rectangle on screen is used by edit text to request from the system to make a certain area visible in terms of the edit text where the cursor is. Get-focused rectangle implementation is pretty straightforward and simple. You let the edit text to fill in the rectangle, and you just update the bottom of the final rectangle to be the parent's bottom. And you do the same thing for the global visible rectangle. Finally, for request rectangle on screen, again, we let the edit text to request its own rectangle, and then we request another rectangle, which is at the bottom of our parent layout. The number 10 here is just a magic number to define a rectangle at the bottom of the parent. Going back to the edit text configuration and how it works with keyboard, as you all know, when you set the input type attribute to text password, the characters on the screen will be invisible. However, this information is also being shared to the keyboard in order to change its behavior. Now, the keyboard itself is another application that can be installed from Play Store. Therefore, they can define their own behavior based on the signals they get. Since we cannot rely on their behavior, we still have to validate the input on our side. However, being able to using the correct input types and IME options is important to reduce the friction for the end user as much as possible. And when you set the input type to number password, you have a visible change on the keyboard where they show the number pad. If you have a custom component, let's say, and you toggle the visibility of the password, you still want to signal the keyboard that this is a password field, and they should not learn about what the user types. Because you don't want the keyboard itself, which is not under your control, to show back the user, here is your password, I know about it. Because it gets a little creepy for the users. And the cases where you don't want the keyboard to learn is not limited to the password fields. Things like an incognito mode, such as in Chrome, or a promo code in your checkout screen are really things that you don't want the keyboard to learn about. For those cases, you can set, or you can add the no personalized learning flag to the IME options. One more IME option that is important, in my opinion, is flag force ASCII. A lot of times we have seen that developers are expecting when they set the password, when they set the input type to text password, they expect the keyboard to show an ASCII keyboard. However, text password is definitely not a strong signal for them to switch to ASCII keyboard. So if you have an ASCII-only field, such as username and password, maybe you might want to add this flag to IME options. One last case that can happen for applications is the control over the application language, text field language, and the keyboard language. If you are an application such as a language learning application or a translation application, there might be a case where the main language of the application is different than the language of the edit text, which can be different than the language of the keyboard because the user can set any language that they want. If you want to signal to keyboard to use a specific language and switch to that language, you can use set IME hint locales function on the edit text. Since we mentioned that keyboard behavior depends on the keyboard implementation, and they can define their own behavior, there might be times where you might want to learn about which keyboard is active at any given time. You can read the active keyboard from the settings, and this will give you the class name and the package name of the keyboard.
We covered so many fantastic things with text in this talk, but let's see what are some of the key things we should remember. First, in terms of performance, keep in mind that the hyphenation is now turned off by default in Android Q and AppCompat 1.1. So if you need it, enable it. And also, you should use PrecomputedText with RecyclerView prefetch. For text styling, keep in mind the precedence order. If you're trying to style something and you don't see the result, it's likely been overridden by something with a higher precedence. If you need to support multiple fonts in your app, use the custom fallback builder API. To find the font used by the system, use the font matcher API. And then to find all the installed fonts, use the font enumeration API. In terms of edit text, use the theme attributes and the Android text, edit text style to style your edit texts. Make sure you don't use the edit text drawables as actions, so you can enable extensibility and maintainability. And also use IME flags to configure soft keyboard for a better user experience. So these were some top tips to make your text terrific. Thank you.